In this problem, it says for the purposes of constructing modified box plots, outliers are defined as data values that are above Q3 by an amount greater than 1.5 times the interquartile range, or below Q1 by an amount greater than 1.5 times the interquartile range. So we're going to use this definition of outliers to find the probability that if a value is randomly selected from a normal distribution, that it turns out to be an outlier. So what we're going to be looking at in this problem is a lot of information about the relationship between the placement of a z-score on the horizontal axis versus the area under the curve. So we start out by saying, well, let's assume we're talking about a standard normal distribution. And so I'm going to put 0 in the center here. And I'm going to mark off where Q1 should be. Now, Q1 is going to define the lower 25% of the data. And that is actually roughly going to turn out to be right about here, as we will see. How would you know this at this point? You wouldn't. So we're just going with that is where that's going to happen, and we'll see why that is when we do some calculations. And then Q3 is similarly going to fall right about here. So you can see the symmetry there, or there would be symmetry if I had this scooched over just a little bit. I think we want to scooch that over just a touch. And you don't have to be this accurate, but I'm trying to give you a nice accurate graph. That's about right. And the other one should probably scooch a little bit to the left as well, but we're going to roll with this. So they are symmetric about that center 0. And what do I know about Q1? Well, I know that 25% of values fall below Q1. And I know 25% of values fall above Q3. So that means in the middle here, there would be 50%. So now I want to know, well, what is the number value? What is the z value associated with Q1? So I can calculate this on the graphing calculator. I can say that Q1 is going to be inverse norm of 0.25, and we put in 0 and 1 for the mean and standard deviation. And what we find out is that that's equal to negative 0.67. So I'm going to put a negative 0.67 there by Q1. So we can see this is negative 1. Now you can see why I knew where to place Q1. I didn't make the right first guess when I was first doing this problem. And then when I went over it again, I said, oh, okay, well, it's at negative 0.67. Now I know where to place my line. So that's how I knew that in advance. You probably would not know that in advance. Now we're going to find Q3. And similarly, I'm going to say, well, what percentage of values fall below Q3? And that's 75%. Fall to the left or below Q3. So when I put this into the calculator, I get positive 0.67. Okay, so now I know where those are. And now I can calculate my interquartile range. And that's just Q3 minus Q1. One problem-solving strategy in math is if you don't know quite what to do in a problem, look at what definitions they give you. So they talk about interquartile range. Okay, let's find out what that is. But I find that, I have to subtract Q3 and Q1, so I need to find out those values. So that's one way to approach this and then see how it all comes together. So here I get 1.34 when I do that. And so what that means is that this distance, that's my interquartile range, I'm going to multiply that by 1.5 and subtract that from Q1. So Q1 minus 1.5 times the interquartile range turns out to be negative 0.67 minus 1.5 times 1.34. So I put in the value of Q1, negative 0.67, and the value of the interquartile range. And when I do this, I get negative 2.68. So that tells me that's where that value, that's where the cutoff for the outliers is going to be. So where is that? It's going to be roughly here. So anything out here is going to be an outlier. Anything including that negative 2.68. So what is the probability that if we select a value randomly that it's an outlier? So I can find this area, but I also need to look at what is the value at Q3 plus 1.5 times the interquartile range. So I'm going to put that down here. Q3 plus 1.5 times the interquartile range. And as you might have guessed, because of the symmetry of this distribution, that's just going to be positive 2.68. So let's locate that. And anything above that or equal to that is also going to be an outlier. So now I want to find the area here and here. How I'm going to calculate that is I'm going to say, just for ease of calculation, I'm going to do 1 minus the area in between. So what is the probability? So I'm going to do a normal CDF to find probability. And I'm going to say, what's the probability that I would fall between negative 2.68 and positive 2.68? So that is the probability of not getting an outlier. If I subtract that from 1, that's the probability that I do get an outlier. And when I do that, that's how I get 0.007. And that's how you do that problem.